Hello everyone, in this video we are going to write down the isomers of C3H4. This elemental composition would fit into the general molecular formula CnH2n minus 2. Therefore, the degree of unsaturation for this elemental composition is equal to 2, which we can prove it. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2. Therefore, this is equal to 1 plus 3 minus 4 by 2. Therefore, this will be equal to 4 minus 2 and that is equal to 2. This means we can write structures that contains 2 carbon-carbon double bonds or 1 carbon-carbon triple bond, that is another possibility, or 1 carbon-carbon double bond plus 1 ring. These are the 3 possibilities. So, therefore, let us write the structures one by one. Number 1, we can write cyclopropene. This is cyclopropene. And then number 2, we can write propyne, that is hydrogen and then carbon triple bond and then carbon and then CH3. In bond line notation, it would be written this way: triple bond and then CH3. And the IUPAC name is propyne or prop19. We don't need to specify the number because wherever we put the triple bond, it would become 1. So, propyne is fine. And then number 3, we can also write allene, that is another structure: hydrogen, carbon, hydrogen and then double bond, carbon and then again double bond, carbon and then 2 hydrogens. Keep it in mind that the allene structure is not totally planar, and the IUPAC name for allene is propa1,2 diene. Sometimes it is also referred as cumulene because successive double bonds are coming. Therefore, it is referred as cumulene. Now, let us talk about isomerism among these 3 molecules. 1 and 2 are ring chain isomers. Some of you might be thinking that why they are not functional group isomers, and the reason is, remember the order of precedence for different isomers: ring chain isomerism first and then tautomers and then functional group isomers, then metamers, then chain isomers, then position isomers. This is the order that we need to follow when we talk about various kinds of isomerism, and therefore 1 and 2 are ring chain isomers. Indeed, they have 2 different functional groups, but when we are calling, we have to call them as ring chain isomers. How about 1 and 3? 1 and 3 are also ring chain isomers. How about 2 and 3? 2 and 3 are functional group isomers. These are the 2 kinds of isomerisms that are possible among these 3 molecules.